Welcome everyone to Dr. Carminati's YouTube channel. I'm thrilled you're here today as we dive into an exciting and cutting-edge topic, OpenAI's PaperBench, a groundbreaking benchmark that tests how well AI can replicate scientific research. Whether you're a tech enthusiast, a curious beginner, or someone who's never heard of AI benchmarks before, this video will guide you step by step through what PaperBench is, why it matters, and what it means for the future of artificial intelligence. I'd love to hear your thoughts, so please drop a comment below. Hit that like button if you enjoy the video, and subscribe to join our growing community of learners and explorers. Let's get started! Imagine a world where artificial intelligence doesn't just follow instructions, but actually conducts scientific research, designing experiments, interpreting results, and even writing papers, just like a human scientist. That's the dream driving projects like PaperBench. OpenAI, a leader in AI development, launched this benchmark to measure how close we are to that reality. Specifically, PaperBench evaluates AI agents' ability to read, understand, and reproduce complex research papers from scratch. Think of it as a test. Can an AI take a scientific paper, figure out what the researchers did, and then redo the work to get the same results? If that sounds ambitious, it is, but it's also a critical step toward understanding AI's potential in science and technology. Let's break this down for those of you new to the topic. First, what's a benchmark? In the world of AI, a benchmark acts like a standardized test. Developers use it to compare different AI systems and see which one performs best at a specific task. For example, some benchmarks test how well AI recognizes images or translates languages. PaperBench, however, focuses on a much tougher challenge, replicating AI research papers. These aren't simple articles, they're dense, technical documents filled with math, code, and jargon. The papers OpenAI chose for PaperBench come from the 2024 International Conference on Machine Learning, or ICML, a top-tier event where researchers share cutting-edge ideas about AI. So how does PaperBench work? The process starts with a collection of 121 research papers from ICML 2024. OpenAI selected these papers because they represent the latest advancements in machine learning, a field where AI learns patterns from data to make predictions or decisions. Each paper describes a unique experiment or innovation, like a new way to train AI models faster or make them more accurate. The goal? Hand these papers to an AI agent and see if it can recreate the research independently. This means the AI must read the text, understand the concepts, write code, run experiments, and produce results that match the original paper's findings. It's like asking a student to redo a science project based solely on a textbook description, except this student is a machine. Now you might wonder, why is this a big deal? To answer that, let's think about human scientists. When a researcher publishes a paper, other scientists often try to replicate the work to verify it. Replication ensures the results hold up and aren't a fluke. But replication takes time, effort, and expertise, sometimes years. If AI could handle this task quickly and accurately, it could revolutionize science. Imagine an AI checking hundreds of papers in days, flagging errors, or even suggesting improvements. That's the vision. PaperBench tests whether today's AI is ready for that role or if we still have a long way to go. Let's dig into the details of how OpenAI set up this benchmark. They didn't just throw papers at the AI and hope for the best. They created a structured challenge. For each of the 121 papers, they defined specific tasks the AI must complete. These tasks vary depending on the paper. Some papers focus on theory, requiring the AI to prove mathematical equations. Others involve coding, where the AI builds and trains machine learning models. OpenAI also provided a scoring system to measure success. Scores range from 0% to 100% based on how closely the AI's results match the original papers. For coding tasks, they compare the AI's output, like accuracy scores or speed, to the paper's reported numbers. For theory tasks, they check if the AI's proofs align with the original logic. To make this fair, OpenAI gave the AI agents access to tools humans might use, like Python coding environments, math software, and even the internet for extra research. They also tested multiple AI models to see how they stack up. Among the top performers was Claude 3.5 Sonnet, developed by Anthropic, paired with some open-source helper tools. This combo scored an average of 21% across the PaperBench tasks. That number might sound low, but it's a giant leap forward when you consider the complexity involved. For comparison, other models, including some from OpenAI itself, scored lower, showing just how challenging this benchmark is. Let's pause and unpack that 21% score. Does it mean AI is failing? Not at all. It means we're at the beginning of something big. Replicating a research paper isn't like answering a trivia question. It requires deep reasoning, problem-solving, and creativity. A human scientist might struggle with these papers too, especially without years of training. The fact that an AI can achieve even partial success, like writing functional code or solving equations, shows incredible potential. Still, 21% tell us AI isn't ready to replace human researchers yet. It might nail some steps, like coding a model, but stumble on others, like interpreting vague instructions or debugging errors. To help you visualize this, picture a paper about improving image recognition AI. The original researchers trained a model to spot cats in photos with 90% accuracy. The AI agent reads the paper, writes its code, and trains a model, but its version only hits 70% accuracy. It's close but not perfect. Maybe it missed a key detail in the paper, or perhaps the paper itself left out crucial steps. This gap highlights a challenge PaperBench exposes. AI struggles with ambiguity. Human scientists often fill in blanks with intuition or experience, skills AI hasn't fully mastered. Another fascinating angle is how PaperBench reveals differences between AI models. Claude 3.5. Sonnet, for instance, outperformed others partly because of its scaffolding, extra software that guides it through complex tasks. Think of scaffolding as a tutor helping a student break down a problem. This suggests that raw AI power isn't enough. Innovative design and support tools matter too. OpenAI's models, like those behind ChatGPT, didn't lead the pack here, which might surprise some fans. But that's the point of benchmarks. They uncover strengths and weaknesses so developers can improve. For beginners, here's a simple analogy. Imagine PaperBench as a cooking competition. The AI gets a recipe, say for a chocolate cake, from a famous chef's cookbook. It must gather ingredients, mix them, bake the cake, and make it taste just like the chef's. A 21% score means the AI baked a cake, but it might be too dry or missing some chocolate. It's edible but not a masterpiece. With practice, it'll get better. And that's what excites researchers about PaperBench. It's a roadmap for training AI to cook science like a pro. What does this mean for the future? If AI keeps improving at PaperBench-style tasks, it could become a scientist's best friend. It might speed up drug discovery by testing hypotheses faster than humans can. It could double-check climate models or design new materials, all while humans focus on big-picture ideas. But there's a flip side. If AI gets too good, some worry it could outpace human oversight, raising ethical questions. For now, though, PaperBench shows we're far from that point. At 21%, AI is more like an eager intern than a mastermind. Let's wrap up with a call to action. PaperBench isn't just a tech story. It's a glimpse into how AI might shape our world. Whether you're amazed, skeptical, or just curious, I'd love to hear from you. Drop a comment with your thoughts. Do you think AI will ever match human scientists? What else should it learn? If you enjoyed this deep dive, please hit the like button. It really helps the channel grow. And don't forget to subscribe for more videos where we explore the latest in science and tech, breaking it down so everyone can join the conversation. Thanks for watching, and I'll see you in the next one.